Hello all, very good morning. Thanks for joining the session. Let me share my screen. I believe this is the demo 5. Yeah. So in our last demo, we discussed about the um, course content, right? Microservices course content is what we have seen. So today, let's continue and then uh, give you overview about the Spring Cloud content as well, then Docker content. And from tomorrow onwards, let us start the Spring Core, and which is very, very important. Spring Core is which is very, very important for our Spring Boot implementation. So in our last session, we did discussed about the, I just have given an overview, honeycomb phonology, how the honeycomb phonology, how we can understand the microservices with the honeycomb phonology. Meaning I'm just setting an expectation at this moment. It's not the discussion of the content, but setting an expectation. Probably, so most of you folks might join today as your first session, probably, but the intention of this session is microservices architecture implementation with the Spring Boot. And once after this ecosystem has been implemented, this ecosystem we need to surround with the Spring Cloud components. So meaning microservices, we need to surround with the Spring Cloud components, various microservices patterns we have to use, and then we have to make it as an ecosystem. So this ecosystem is what we need to build throughout our sessions. So what are required to be built this ecosystem, first of all? So the required knowledge or the required prerequisite is just Spring Core and Java 8. If you don't know Spring Core, since beginning I'm telling, 3 weeks I will start Spring Core, and then 3 weeks I will tell the Spring Core, which will be helps you to understand the Spring Core container internals, like how it will work, and top of it how the Spring Boot will works. Why I'm telling every time the Spring Core is really important. So because the concepts like Spring Core, how the Spring framework will work, and the basic idea of the conversion of Java beans to the Spring beans, and then the difference between the Java bean and then Spring bean. So various important interview questions were there, not only interview, but in order to understand the internals of it, you have to know about the Spring Core. Okay, fine. So if you can see my screen, I just have share you the screen. So my intention is you need to know about the internals of it. Internals of it in the sense, while we are discussing about the Spring Boot, we will see the how this application will work internally. So meaning let's go and then see its source code. So when you go and then see its source code, what is happening, right? So we need to understand what is this configurable application context. First of all, what is application context? What is this configurable application context? And not only this, if you can see, there are lot of other concepts, the initializers. So what are the initializers in Spring, right? And then what are these listeners, right? And then how these initializers and listeners will work. So this level we need to understand. This level we need to understand. For example, we get Spring Factories instances. Now here we need to understand what is the Spring Factories, how the Spring Factories will be created, meaning the bean creation using the factory method, factory pattern, all these things we need to see. Right. So internals of the Spring Boot we will see, where everywhere the Spring Core is very important to understand the internals of the Spring Boot. Right. And also on top of the Spring Core only, the Spring framework, Spring Core is the basis for entire Spring framework. Similarly, it is also basis for our Spring Boot as well. Of course, it is on top of the Spring framework. Right. So once, if you can see this internals of it, now here calling the run method, see here new operator is used, and everywhere if you can see here, some listeners are creating, and you have to know from the Spring Core that is the what is this configurable environment, what is the application context, how to refresh the context, after refreshing the context, preparing context, meaning bean life cycle, Spring Bean life cycle is what we need to know actually, right? So if you can see this prepare context, lot of things are happened here actually. Don't worry, it is very easy actually. It is very easy. But when you know the Spring Core, importance of the Spring Core, I'm setting to you here. And see this here, Bean Factory. What is Bean Factory? What is application context? What is this configurable listable Bean Factory, right? So this is registering the singletons. What is singleton, right? Scope of the Spring Beans we need to understand. And then listener here used. So listener is used and then context prepared. For this listener, whatever the context prepared it is setting. Of course, lot of things we will see going forward, lot of things we will see. But you got now some context about the Spring Core, right? So if you know the Spring Core very well and in depth of the Spring Core very well, then it is very easier for you to understand the Spring Boot. Okay, so that is a prerequisite for the Spring Boot learning. Why we are learning the Spring Boot actually? Because our end target is to build the ecosystem. So the ecosystem we will build using the microservices, and the easiest one of the microservices principle is what you know. One of the microservices principle is what you know, autonomous. Autonomous microservices should be autonomous. So that autonomous capability is given by our Spring Boot framework, Spring Boot utility framework. So that is the reason here we are using the Spring Boot. Not only Spring Boot, you can use any framework, any tool to implement the microservices. Remember, microservices are again architectural pattern. To implement that architectural pattern, we can use any technology, any language, anything. So here microservices also we can implement with any technology, any language. This is called as polyglot nature of the microservices. Polyglot nature of the microservices. So such microservices in order to implement very easily, the autonomous capability is given by our Spring Boot. That is the reason we are using, being a Java developer, we have the one and only one super option to implement the microservices is to use this Spring Boot, because it's an auto configurable framework which is giving by default all the capabilities required to microservices implementation. However, there were a lots of challenges in microservices implementation. So let me showcase you the interview questions, how they are asking. Of course, in our last week also we discussed, but I just would like to set you the expectation to which level you have to learn the microservices. So if you can carefully observe here, so the difference between the service oriented architecture and then microservices. So, meaning here you need to understand the architectural evolution, and currently what architectures we are using. So architectural evolution, when you understood, then you will be able to answer this question. And this question you can see, isn't in process communication in monolithic application faster than the tons of remote network calls in microservices architecture? What he is saying, in microservices architecture, when one service needs to talk to another service, remote call need to do, network call need to do. Isn't it a costly thing when compared to all the things implemented in a single application, like your monolithic application shown here? So that's what he is talking about. See, if you work on it, if the products, orders, categories all are in a single application, this can be communicate each other because deploying in a single Tomcat container. But this architecture, when you say this is having its own Tomcat, this is having its own Tomcat, this is having its own Tomcat. Every application is an independent process. So how this process communication will be, and isn't it be a costly when compared to the monolithic application is the question, right? So we have seen there were a very good packages in microservices architecture, isn't it? So you can get very good packages, but the interview questions are also will be like that. We need to be able to answer them. See, challenges in microservices, damn sure question. What are all the especially for 2 to 3 experience of engineers, the guarantee question is what are the challenges you have seen in microservices implementation? That is the very confusion question for 2 to 3 years of engineering guys. Sir, challenges what confusing? The confusion is if I can ask you the question, what is the difference between RESTful service and microservice? If I ask you a question, RESTful API and then microservice, what is the difference? That is tricky question. It's not so easy to answer. All RESTful services are not microservices, but all microservices are RESTful services. Then how you will justify that, the difference between the microservices and then RESTful services, right? So that's the question they will ask. So RESTful services versus microservices. So if anyone will ask this question, it is a tricky question. At least for me, it is a tough question. I don't know about you, but for me, it is a tough question. So all microservices are RESTful services, but all RESTful services are not microservices. So this level of understanding is required to you. All RESTful services are microservices, but sorry, yes, all RESTful services are not microservices, but all microservices are RESTful services. All microservices are RESTful services. You got the difference? All RESTful services are not microservices, but all microservices are RESTful services. No, you need to thoroughly have an understanding on RESTful services. Very in-depth knowledge on RESTful services, RESTful API design is required. So that's what we will do in our monolithic application implementation, where we will do here. Spring Web MVC we will use, and we will complete this application. Then we will use the Spring REST also parallelly to implement here. So later that RESTful services we will convert into microservices by applying the various microservices principles and characteristics. Okay, maybe my terms are little bigger to you. Whatever I'm telling now may not be understand for you at this moment, but what you have to learn is very important. Basic level of understanding, basic level of learning doesn't gives you the good opportunities. So of course, basic is very important. Plus, in depth of each and every concept is also very important. However, now I would like to showcase you the code. How much of code we will implement here, just to give you the confidence. I'm showing all these things just to give you the confidence. I'm showing all these things. For example, see this. So resilience patterns, event sourcing, gateway security, saga pattern, lot of things we will implement here. See what we happen. We have the gateway. That means this is the gateway, and this gateway is with the registered with the registry. See, here is the service registry for us. This is the service registry, right? And what this gateway is doing, gateway is talking to this user management service. So go to here, go to SRC, go to main, outbound communication, so user management fin client. See this, it is speaking to this user management. So user management. So the user management is doing what? User management is talking to our identity server and getting the token. So this is giving the token. So meaning this is giving the user details, logged in user details based on the token. Right now, if you can see the code, what we are doing here in the gateway, just I would like to showcase you the what extent you will learn is I'm trying to showcase it to you. So go to gateway. Here we have implemented gateway authorization filter. So what we are doing from the request, we are taking the headers, meaning from the request, we are getting the, so Angular application, React application is there. So Angular application will send a token in the request header to the gateway. So gateway is taking the token, right? And this token, with this token, it is trying to getting the user profile by talking to user management service, isn't it? Gateway is talking to user management service and get the logged in user profile based on the access token that it is getting from the UI. If the access token is valid, then it is further continuing. If the access token is invalid, it is just throwing an error saying that, forbidden. You don't have the access to access the backend microservices. You are forbidden to access the backend services. Right? If it is yes, then what we are doing? We are allowing the call to the next services. For example, gateway validated the token and then it is passing to the further services. So let us go to this category service just in case. So the category service will have a lot of things in it, right? Resources, handlers, lot of things we have here. Config, lot of things we have here. Event sourcing config. Right now, this will gives the service details. For example, brand service. So this brand service requires the again the category services. So if we can go here, lot of packages, beans, secures, domains, exceptions, interceptor, outbound, repos. In this interceptor, what we are doing, lookup entity, command line interceptor, lot of we are doing. Again, what are these interceptors, sir? We'll discuss later in time, but I'm just showcasing the standard of code that we will write. For example, the standard of code I would like to showcase you, outbound communication. See this, what we are doing. Just let it come back, what it is doing. See, so this is the REST template we are used. And the later in time, what we did, this REST template having some issue, then we replace it with the fin client. See the fin client. Now the important interview question is, what's the difference between the REST template and fin client? Why we are using the fin clients? Remember, fin clients are interfaces, no implementation, but we are using very frequently in our real-time project. If you do the real-time, you have to use the fin client in microservices communication, which is very, very important. Here, if you can see, product service is speaking to this category service to get all the categories here to create a product under a category. To create a product under a category, it requires the category service details. For example, if I can go and then showcase you the source code of this controller, how it will be, resources, product brand. In REST services, in REST terminology, everything is resource basically. So if you can see here, this is the creating the brands. See, product brands, everywhere the name of the resource is same. Product brands, product brands, product brands. If you observe, product branch. The name is same because we implemented it according to the REST standards. As per the REST standards, the resource name should be a noun. It should not be a verb. That is the reason we have not taken like get all products, get all product, delete product, and get all products by ID. No, those are actions. This can be method name, can be any, but here we have to take the names only. This is a REST standard. What I would like to tell you now, using the REST standards we implemented. See, complete realistical implementation it is. The multi-form data value, because the product might upload the images as well. Do you understand here? At a time, two different types of data this service is taking. Multi-part data plus application JSON data. Both it is taking at a time. At a time. This is very important. And then complex scenario. This in real time, you will get this scenario 100% you will get this scenario in real time. Okay, so what I would like to tell you is we are using the Spring Boot to implement the microservices of industry standard. Okay, there is no doubt at all in it. For example, let me go src main resources. You see this application.yaml file, how we have written it, how big it is. Do you see this? How big it is? Resilience pattern we implemented, circuit breaker, resilience 4J, right? Retry patterns. How big it is? The YAML file. And see how we have written branch port, DB host, parameterized configuration is what we have used. Parameterized configuration. Sir, why you have used this parameterized configuration? Because later on time, when we write our Docker compose files, we can supply the values to these parameters from the Docker compose file. That means now you have given the by default value as 3306. By default database name as Shopify me product branch database. But later in time, you can give any database name, supply the values to these property sources from an external place. So to do that, we have given this parameterized approach we followed. So into this parameterized approach, see this, we will supply the values like this using environment, we'll supply. Not only here, later in time, of course, that is out of syllabus for you, but later in time, when Kubernetes will come into the picture, but not for you. So in Kubernetes also, we will set the values for this environment variable. See this database name, root password. So if you can take the code like a parameterized, so you can supply the values from an external source by changing like anything. So that is the benefit that we will have. See, we already have used the Swagger API documentation. We implemented using the Open API Swagger we used. Okay, so what I'm trying to explaining you is the level of the, see here, AMQP services. That means what? We have used the RabbitMQ as well here, right? And then we have used the Axon framework for the CQRS implementation. Don't panic, sir. We don't know Spring Boot. Can we do at this level? Easily we will. That's what you will spend 90 days with me. Not one day, today, right? 90 days you will spend with me. In 90 days, we can do like anything. So this is Spring Boot we have used. See this. What is this parent by parent? And what is this dependencies? Especially what is this plugin? Right? What is this plugins? Right? So lot of dependencies we have taken. Few are the custom dependencies, few are the inbuilt dependencies, but lot of dependencies are we have taken. You got it now? In which level we implement our application. So this ecosystem we will implement using the microservices. Not only this, if you can see here, only 5 to 6 microservices you are seeing. But when we implement the 4 use cases, at least 4 into 4, 16 microservices will come. The interviewer will ask you how many microservices you were written. Then you have to answer him like, I have written 10 microservices. I have written around 10 microservices or 15 microservices. Like that you have to answer. Right? So when you work on it, you will answer the question. However, let us go and then see now the importance of these microservices, meaning the architectural importance you guys will see. Now, what is the important interview question they are asking? Let us see. Of course, at this moment, these are not required for you, but I'm just setting up the expectation. See this. How to maintain assets in microservices architecture. This is not so simple. How to maintain asset in microservices architecture, right? That means what? A transaction management in microservices architecture is he asking. And series, what shall be preferred communication style in microservices, synchronous or asynchronous? So if you can see the source code so far, what we did, I mean, what I can show you, what the source code I have seen, there is a saga pattern. The saga pattern we have used for the shipment service, order service, payment service. Did you see there? Product service, brand service, category service. Here shipment service, order service, and payment service. Total 8 microservices, 7 microservices you got. And there is the common APIs project also there. So what you are understanding here, this is the asynchronous communication we could say. So we are using the saga pattern. And just now, I have shown you the fiend client, which is a synchronous communication. So interviewer is asking which communication you would prefer, synchronous communication or asynchronous communication. So a lot of discussion need to do here. Next, what is difference between orchestration and choreography in microservices? So orchestration, what is orchestration? What is choreography? We need to understand. Again, we will follow the orchestration model. Choreography model have some limitation. We'll go with the orchestration model. So when you understand all these things, when you have the subject thoroughly, then you will understand. See this, how to maintain the transactions in microservices. The answer is saga pattern implementation will gives you the answer. Event driven microservices will gives the answer for maintaining the assets, meaning transactions in microservices. Atomicity, consistency, isolation, and durability. How all these will come in microservices architecture. So why we are discussing here ACID in microservices architecture? Because in our monolithic architecture, we easily can implement it. Did you remember in our microservices, meaning Spring Boot course content, I have shown you the transactions, in depth of transactions we will discuss, I told. So that transactions, okay, we can easily perform within a single or same application. Within the same application, we can perform the transaction. This is the application. Within the same application, the transaction context will be created, which is common for all the modules, so that we can easily maintain the transaction. That is okay. But in microservices, see this, there is a in-depth discussion of the transaction management is what we are doing here. So this transaction management discussion will help us to understand the asset properties in transactions, and how do we maintain the assets. This transaction context is never known to this transaction context. How the transaction, for example, payment failure. The payment fail, order need to be revised back, product need to be updated in its product go down, Go down have 10 products. I ordered for 2 products. Now the go down will be updated with 8 products only. Right. But when payment fails, the products should have to be reset to 10, not 8. Isn't it? So how this is happening based on one service, one microservices decision, how other microservices will reset its database things. So these are all the things that you need to learn in the microservices implementation books. It's not so, it is easy. I'm pretty sure it is very easy when you are mastering Spring Boot. Spring Boot is very easy when you are mastering Spring Core. Spring Core is very easy when you are mastering Java. Of course, no one is mastering Java, but at least if you are proficient in Java, then Spring Core is very easy. The Spring Core is very easy. Spring Boot is very easy. When Spring Boot is very easy, microservices are very easy. It's interlinking technical things that you need to learn. Okay, so I'm just giving you the general discussion here to setting up the expectation, like to what level you will implement, to what level you will learn here. Because someone might ask the question, sir, are we using the Kafka? Are we using the RabbitMQ? Are we using the Zipkin? Right? Yes. If you can go here, there is resilience patterns. Let's go to resilience pattern. So did you see anywhere the resilience pattern in our architecture? Yes, resilience 4J. So where we have to implement it, we have to implement it on the gateway, API gateway that we gonna write. And did you remember day before yesterday, I have shown you in the place of WS42 identity server, we will use the key cloak, right? Key cloak is an IDP, where in the place of WS42 we can use a key cloak, where users, applications, multi-factor authentications, single sign-ons, and token generations all will be given by these IDPs. In microservices architecture, one usage of the IDP is must and should. So interviewer will ask you, you are showing, for example, 3 years of your fake experience or 4 years of fake experience, 5 years of fake experience, you put in your resume and attending the interview. The interviewer will ask you, like, are you using any IDP, or how you are generating the JWT tokens, which will gives you the single sign-on capability. I have seen JWT token creation logic is, of course, now people are explaining in American institutions. That is fine. But how the single sign-on will be happened with that JWT token is, again, I don't see anywhere. So the importance of it you have to understand. Once the user will be get one token, he can be able to log into any of the microservices. And also, for example, I have a Facebook, I have a Google credentials. With those Google and then Facebook credentials as well, we will be able to log into this application. Can you please be mute? Yeah, I will give some time to answer your questions, ask the questions. Right now, I'm setting the expectation, like at what extent you will do. And did you remember I told we will also implement, integrate our microservices later in time with the React.js. React.js theory, I don't tell you, but React.js integration, I will tell you. For example, this is React.js, very easy React.js service component. So there's a department service, login service, sign up service. So how this sign up, how this login, how these are happening. So if you can see here, sign up service. So it is calling our backend API. and then making the user to be registered. And then if you can see this department service, it is calling the department service to get the departments. See here we are sending the token as well, bearer token also, security token also we are sending to call this API, because this API is secure, na? So you got it right, how the token is sending from the UI. From the UI, the token is sending, isn't it? In a header. In a header, the token is sending. This token sending to whom? Sending to our department service, meaning some microservice. But in the middle, who is there? There is a gateway. So this is the gateway URL actually. So gateway will intercept the token, validate the token. Once the token is valid, then only the department service will be accessed. Got it? So now how the token is sending from the UI. So these are all the things we will discuss. See, now the application is starting up, the React.js application. Microservices, for microservices, in my opinion, React.js is the very lightweight and then very easy to implement, very lightweight UI compared to Angular. React is very, very lightweight UI. So the applications which I am architecting, I'm always proposing React.js as the UI. Of course, for 2 to 3 clients, they were migrated also to the React.js, getting good results because performance-wise it is very fast. We can easily convert to the mobile applications using the React Native. A lot of other benefits also we have. That's the reason I have chosen the React.js as well. React.js as our UI framework. So the scope, what is the scope of this course? Sir, you told lot of things, but we are not understand what we will learn. So you will learn throughout this course, you will learn Spring Boot, you will learn microservices, you will learn Spring Cloud, you will learn, and Docker you will learn. And of course, as part of the Spring Cloud, lot of microservices patterns we will implement to build this ecosystem with the external services like ELK, Kafka, Grafana, Jepkin, right? A lot of other tools we will embed and then make a complete ecosystem. And later this ecosystem, we will integrate with the UI frameworks. So up to this level, you will learn. Okay, so that is the expectation of this course. See, now React application is started. Of course, backend services are not ready. So this is the login and this is the sign up. So backend services were not ready. That's the reason we are now not able to see the backend data. But so this is what the React.js application using which we will implement the meaning we will integrate it with the backend services. Okay, so I don't think I have to go to the internals of the React at this moment. I don't want to go there, but one thing you need to understand is what there should be an API gateway before the microservices, which will take the token, validate the token, and then only it will give the access to microservices. So security of the microservices communication, microservices logging, microservices tracing, microservices events. These are all the 5 topics which are very, very important. So microservices security, microservices logging, microservices communication, microservices tracing, and microservices microservices logging, tracing, security, and microservices resiliency. That's it. These 5 concepts of microservices, not concepts actually, these 5 implementations with the microservices will give you the job. Many of the people will feel, you know, they know microservices, but they really don't know microservices, in my opinion, without knowing these 5 things, how to do in microservices. Microservices, security, logging, communication, tracing, resiliency, and microservices registry and configuration server, external configuration server. So this is, without all these 5 or 6 concepts, microservices is incomplete. And if you attend interview, definitely it will be bounced back to you. Interviewers are pretty much interested in security, communication styles, resiliency, and tracing. Of course, these 5 topics are very, very important in microservices. If you know this, you'll get easily the job. If you don't know, if you attend 10 interviews, I'm sure 10 out of 10 you will fail. That's the importance of it. Okay, so please do your registrations. If anyone is interested, from tomorrow onwards, let us start Spring Core. From tomorrow onwards, I will start Spring Core from very, very scratch, very beginning to advanced level. So very beginning to advanced level, I will tell this Spring Core. Spring Core is for 3 weeks. That means 6 into 3, 18 days. 6 into 3, 18 days. Of course, one day maybe I may take half for one day, plus or minus, I can say plus or minus 18 days it will take. Okay, so let us start Spring Core from tomorrow onwards. And if, of course, the demo link will still continue, I believe, but do your registrations as early as possible if you are interested to travel your journey with me for coming up 90 days to implement the beautiful ecosystem using the microservices architecture. Okay, so anything else for me? Do you have any questions for me? Yeah, you can speak to me if you have any questions. Correct. Here we are using the Docker, right? So using the Docker, what we will do, we will set up the EC2 instances. I will do one thing as the question asked at this moment. Let me quickly log into my AWS console. So just we quickly log into AWS console to showcase you what extent we will do. Okay, so as part of the deployment procedure, CI/CD I may not cover to you. CI/CD I definitely not cover to you, but if you can go to my repo, this repo. So everything we will do it from an external configurations point of view. For example, this app deployment monolith app I named, but it is a microservice. I forgot to rename it, but if you can see here, we will write the Docker file. So these Docker files, and we also will write the Docker Compose files. So these Docker files and then Docker Compose files, using this Docker files series, Docker Compose also, volumes concept we have used. Volumes concept we have used, and network concept we have used. Lot of Docker concepts we will use actually. So let me log into, just in a moment, let me log into my AWS management console to showcase at what level and how we will do the deployments. So just in a moment of time, I will showcase, just bear with me till I log in, submit. Just bear with me till I log in. So from tomorrow onwards, let us start the Spring Core. Very, very important, guys. Please join. Don't miss the 18-day sessions, which will give you a lot of confidence and which will help you a lot to start the Spring Core. So now
yeah, we have one query. Hello.
Go ahead.
Yeah, suppose if I miss that section, can we get to record section next day?
Yes,
because we are traveling or any, if I
correct. Recordings will be given on day-to-day basis, and recordings will be valid for 6 months.
Yeah, thank you. Because 90 days means some days we will miss. We will see the videos next day. Yeah,
Correct.
thank you.
That's true. That's true. Okay, if we can go here, the instances in the Virginia region. So like this, we will create one Docker machine. So in this Docker machine, what we will do is we will run our microservices as a containers. So we will create one machine called Docker machine. In the Docker machine, we will install the Docker and then we will run our microservices in this Docker machine. This is one deployment. Second is what, before starting the Docker, I will tell you the Elastic Beanstalk. This is the charged one actually. So first we'll start with it before our Docker, this Elastic Beanstalk we will start, and then I will let you know how to deploy. See this application name and then choose the platform, which platform you would like to, meaning my platform is Java, and platform version, what Java 7, Java 8, or is Corretto 11 is the Amazon Linux 2 JDK. That's okay, that is fine for us. And which one you want? You want to run a simple application, sample application, or you want to upload your code? I want to upload my code. So how you want to upload? Upload from the local URL or upload from the S3 bucket? Local URL. Then upload your WAR file or jar file. So we will upload our jar file or our WAR file. Then we will create an application. That's it. So Beanstalk will run our jar or WAR file and then deploy in the cloud. But it is the charged actually. So that is the reason what we will do. We will create the Docker containers and then Docker containers will be deployed in a Docker machine. So one EC2 machine we will take, which is of size 1 GB we can take. 3 machines, we can take 4 or 5. How many microservices we have? Those many free machines we can take and then run those services as a Docker containers here. So load balancer we will use here because in the architecture, if you can see, everywhere we have used the load balancer. So what kind of load balancer we will use? Application load balancer we will use. And of course, if you can see, everywhere I have taken VPC, VPC, VPC. Virtual private cloud I have taken. So meaning whatever I have written here, folks, implementation wise, exactly similar. So VPC is here, but in order to talk to this VPC, here, this is in another VPC, public network. These are in private networks. So we need a NAT gateway. This is that NAT gateway. So I'll explain the concept of VPC, explain the concept of NAT gateway, explain the concept of load balancers. But when we are going for the deployment, production setup, once our ecosystem is ready, then the next thing is our production deployment. There we will go for all these concepts. Are we using multi-mode pattern? Multi-node? Yeah, actually. Huh. Yes, we'll cover web services mean RESTful services. Correct. RESTful services only will cover, and those are all required to you. So when will be given new link as I have got registered? Yeah, Amir, new link will be, let us we will give the new link once after the registrations will completed. Just 2 to 3 days of time it will take. So between classes, if you got any doubt, can we ask? Yeah. You can mute first, raise your hand, or else type your question in the middle of the class. I will speak out it, and then you can speak to me. Okay. Yes, teaching us how to do all configurations also. Correct. About everything from the scratch. Otherwise, you can't understand. Na? For example, how to set up we are going to use STS IDE. This IDE we will use. So far you might have worked on the Eclipse IDE. It is similar to that, but how to use it and all also I'll explain. So for Java developers, IntelliJ is the IDE most frequently is using. IntelliJ. But that IDE is available in 2 flavors, commercial and then the open. but open is limited for few days only. So commercial one we have to use. So as it is commercial, we are going with the Spring Tool Suite, which is very beautiful tool for the Spring Boot implementations. The default support, inbuilt support is there for the Spring Boot configurations. So that's the reason we will use this IDE. So how to set up this IDE, how to download and all, I will explain. So from the very scratch, everything we will see from very scratch. Don't worry. Yes, you guys gonna learn Docker concepts as part of this course. Yes, Docker in depth you will learn, because nowadays Docker is asking for the developers. Every interview, everyone is asking Docker, because targeted system we are implementing is microservices. These microservices will deploy later in the Kubernetes. So in order to deploy these microservices in Kubernetes, then we definitely have to know the Docker, because we need to create the Docker images. So for every developer nowadays, the Docker is mandatory. Right. Do you suggest to learn React separately? Yes, it is good idea. If you have really interest, parallelly, if you learn the React.js, that is very, very helpful for you folks. You will become a full stack developer and you can demand a very good high salaries. Parallelly, when we start Spring Boot, right? Spring Boot, we have not started yet, but Spring Boot, when we start day one, if you parallelly also start learning the React.js, that will saves a lot of time to you. And within the 90 days of time, you will become a full stack developer. Yes, do we have a software list to install at primary stage? Yes, we have the list of softwares that we need to install at the primary level. So all these things I will provide. If you can see the tools that we're gonna use. Yeah, any questions?
Yes, sir. One more thing. As you said, if you learn full React.js, you will become a full stack developer. So only React is mandatory for this course to become a full stack developer.
Not only React. What I mean to say is we have this backend services, right?
Right.
Microservices architecture experience with you. So parallelly, this microservices needs to be integrated with the UI frameworks like Angular or React. So preferably, I will prefer the React here. So when I'm doing the integration, in order to easily understand, by the time you learn the React, it will be helpful for you. So you
Yeah.
will become a full stack.
Yeah,
The
that's
UI
what I'm
is
saying. Means all other things that we are covering, only React.js we need to learn as a
correct,
separate.
separately. Exactly, separately you have to learn this.
Okay, fine. Thank you.
Okay, so is it possible to start the batch for React.js by you? No. Actually, React.js, again, it will take 45 days for React.js. It is very easy, but I don't start the React.js batch. At least, I have a lot of other things to take up. Back and side, a lot of things we need to do. So the prior knowledge of Kubernetes, Ansible, Jenkins, and no, nothing required for this batch. CoreJava, prior knowledge of CoreJava is required for this one. That's it. Nothing more than that. Okay, so most of you folks asked me the tools list. Yes, I have the tools list. I'm just looking for the material where I have kept this tools list. So I can show you, otherwise I can show you the tools list tomorrow, folks. Okay, the list of tools what we use, I have already prepared a document. The list of tools needs to be implemented, meaning install. So JavaScript knowledge is important for React.js. Yes, JavaScript knowledge is mandatory for React.js implementation. Of course, as part of your React.js sessions, your tutor will explain first JavaScript and then TypeScript. Then only they will start the React sessions. Any more questions? Okay, guys. So if you are interested, and then go and then complete your registrations. Let us gonna change the link probably in coming 2 to 3 days. At most three or maybe 4-5 days. We'll change the link. 3 or 5 days at most. We'll change the link. So go and then do your registrations. Okay, and also Spring Core, whatever the Spring Core we're going to start from tomorrow onwards, right? The Spring Core is for the 3 weeks, and please attend and then utilize that Spring Core. Okay, anything else for me? Any questions? Anything else? Yeah, a lot of questions. Register already. Okay. Yeah. So great. So I have registered and calling admin team to access details. Admin team is not picking the details. Okay, just send me an email. I already got the 2 emails. I will give the material access to them. Whoever are registered, you just send an email to me. Okay, so this is my email ID. Whoever registered, I don't want any payment proofs or something like that, but if you register, then just send me an email. Okay, whoever have registered, who want the access of the material, just send me an email. Okay, don't send me payment proofs or anything, just send me an email. I trust whatever the emails you are sending, I believe you are already registered candidates only. Okay, I will give the link. Yes. Material is with me. Recorded videos backend team will give, but material I have to give. So material access I have to give. So that is the reason material access is is it with me actually. So that's the reason you didn't got the material. So like this, I have created a classrooms here. Usually I'll create classrooms here, all the classes for the Kafka, DevOps, and then SBMS. So lot of material, if it is Kafka, then Kafka material. Okay, so I will add you to the various classrooms to get the material. Okay, so register and then get the material. Yeah. Yes. So for material, mail me, correct. Material, mail me. So this is my mail ID. Just mail me with your email ID. Just mention I have registered. This is my email ID, and this is my of course, for now you just give your email ID. I will give the access for the classroom. Once classroom access got, then there is a Telegram link. Join in the Telegram link. Okay. Yeah. So that's all, folks, for today. Don't miss tomorrow's session. Let us start Spring Core from tomorrow onwards. What is Spring? I will start from what is Spring. Difference between J2WE and then Spring, and how the Spring has been traveled so far from 2002 to 2022. 2 decades journey of Spring. Let us understand. Then let us go for the Spring Core, and slowly we'll understand all the concepts in Spring Core. Okay. That's all from my side. Thank you so much, folks. Hope see you tomorrow. Of course, do your registrations quickly and see you tomorrow at the same time, that is 8:30. Thank you.